Okay, so we're moving into chapter 4. So we had been talking about graphing lines. We're now moving into talking about more like the actual equations of lines. So the place that we're starting is with slope-intercept form. So you've seen slope-intercept form lots of times, actually. Slope-intercept form is the form y equals mx plus b, where the m is my slope and your b is the y-intercept. So we're used to seeing stuff like this. It's just y equals 2x plus 1, right? This is an equation written in slope-intercept form. A function, to remind you of a function, is where every input has one output. Every x value goes to exactly one y value. That's a function. And then the last one, slope, is when we talk about slope is a constant rate of change. And you may remember before we talked about this formula of y2 minus y1 over x2 minus x1. All this is it's telling us that we want to see what our change in y is, and we're going to divide it by the change in x. I also showed you this way of writing it. Triangle y over triangle x, delta y over delta x means change of y over change in x. This is just a much faster way of writing the same thing. So these two things are equivalent, they're the same thing. Writing it this way is just a little bit faster though. So we're going to be using that quite a bit. Okay, so slope-intercept form we've talked about is y equals mx plus b. So when we're given the slope and we're given the y-intercept, it's really easy to just plug in those values, right? So if I have y equals m, my slope in this case is 2, so 2x, my y-intercept is negative 5, y equals 2x minus 5. That's all I gotta do, and then I'm good to go. Okay, we can do the same thing down here. My slope is 1/2, so y equals 1/2 x. My y-intercept is 0, so it's just plus 0. If I add 0 to something, does it change? No, it doesn't, right? So I don't need this plus 0. I could just write this as y equals 1/2 x. And then I'm good. Okay, the last one. My slope is 0 this time, so I would have y equals 0x plus 2. But 0 times anything is just 0. So I could just write this as y equals 2. And then I'm done. Right, so fairly straightforward, fairly simple. When we're given our slope and we're given the y-intercept, all you gotta do is plug it in. Gets a little bit more complicated later on. So let's say we have a graph like this. Let's put a point there. Go up to... Okay, so it looks something like this. Okay, so my y-intercept I can see already is 2. Right, my y-intercept happens right here at 2. Then I need to look at, well, how do I get from one point to the next? So let's go from down here. Let's go like this. Right, well, to do that, I need to go up 2 spaces over 1 space. So my slope is 2 over 1, or just 2. So if I were going to write my equation for this, it would just be y equals 2x plus 2. Let's try another one. Let's do this. Let's go. Let's do this. Come on. 2, 3, 4. Okay. So this time, my y-intercept happens down here at -2. Okay, and then my slope, I'm going down 1 over 4. So down 1 over 4 means that my slope is -1/4. So if I were to write this, I would have y equals -1/4 x minus 2. Okay, there's 2 more graphs on here, so go ahead and choose your own 2 lines and figure out what the equations of those lines will be. We're going to move on to the next page, though. Okay, so it's a little it's easier, I should say, to write equations when we're given the slope and we're given the y-intercept. It's not always going to be the case, though. I'm going to make this a little bit smaller, I think. So I have 2 points here. I need to figure out, well, first of all, I need to know what the slope is. And then I also need to recognize what my y-intercept is. So slope, if you remember, we're going to do y2 minus y1 over x2 minus x1. So I'm going to say this is 1, that's 2. This first one is going to be 9 minus -6 over 3 minus 0. 9 minus -6 is a 15. 3 minus 0 is just 3. My slope is 5 over 1, or just 5. And if you remember, our y-intercept is always going to happen when x is 0, right? So right here is when x equals 0. So my y value when x equals 0 is -6. So my y-intercept is -6. So I have the 2 pieces I need. I can write my equation. Y equals 5x minus 6. And then I'm done. Okay, let's do the next one together and then I'll have you do the last one on your own. So here's my y-intercept. It's the value that goes with my 2. Now I need to figure out slope. So 2 minus -1 over 0 minus 4. So 2 minus -1 is going to be a positive 3. 0 minus 4 is a -4. Slope is -3/4. Now I have the 2 pieces that I need. Y equals -3/4 x plus 2. And that's it. Okay? Go ahead and do the last one, and then when you're done, you can check your answer with mine. Alright, you should have gotten that y equals -x minus 5 after all of that. Okay, function notation is something that a lot of people seem to struggle with a little bit, but it's pretty straightforward. So when you see function notation like this, think of this as a point on a graph. So here's my input, here is my output. So when I put in 0, I get out -4. I can write that as a point, a coordinate point. So that's just going to be 0, -4. That's the first point I'm working with. Second point I'm working with then is 3, 8. Okay, that's it. So now I'm just going to do the same thing that I've done before. So I'll have 8 minus -4 over 3 minus 0. So 8 minus -4 is 12. 3 minus 0 is just 3. Slope of this graph is 4. And remember, my y-intercept happens when x is 0. So my y-intercept is over here at -4. So my equation for this line is going to be y equals 4x minus 4. And I'm done. Okay. Last one here. In 2000, the average cost for college tuition in the United States was $14,000. In 2010, the cost averaged $18,000. Write a linear model, y equals mx plus b, that represents the cost of the tuition as a function of the number of years since 2000. Use the model to predict the cost in 2025. Well, okay, so here's what we have to think about. My graph is starting. I'm starting in the year 2000. So if we think about this on a graph, my years would go down here, and my tuition would go over here. So I'm beginning in 2000. So the tuition in 2000 was $14,000. So everything that I am talking about is going to be in relation to 2000. So that means my graph starts here at 14,000. And it's going to go up from there. So if I were to think about this as a point, right, if this is 14,000 right here, if I were to write this here as a point, it's going to be the point 0, 14,000. I'm starting at 0 because that's where my graph is starting at, right? Like that's 2000 is my initial value. It's 0. So then I'm given another point. The other point that I'm given is that in 2010, the average cost was $18,000. So I have to think about, well, if 2000 is 0, how many years have passed since 2000? Well, 10 years have passed since 2000. So my second point is 10, 18,000. Now I have everything I need. I'm going to find my slope. 18,000 minus 14,000 divided by 10 minus 0. So then I've got 4,000 divided by 10, which is going to give me 400. Means that my slope is 400. My y-intercept then happens right here at 14,000. So the equation for this line is going to be y equals 400x, 400 times the number of years, plus $14,000, because that's where I'm starting, is at 14,000. So this is the linear function. So now it asks me, use this to predict what the tuition cost is going to be in 2025. Well, I'm gonna get rid of this graph over here, and then we can solve it. So, between 2000 and 2025, 25 years have passed, right? So if we use our fun f of x notation, f of 25 is going to be 400 times 25 plus 14,000. So that's going to equal 400 times 25 is going to give me 10,000. So I'll have 10,000 plus 14,000, which is going to give me a total of $24,000. So according to our linear model, according to our equation, the average cost of tuition in 2025 would be $24,000.